Dear friends, now let us consider one more very beautiful problems under Stokes theorem. Verify Stokes theorem for the vector f is equal to, for the function f is equal to vector function 2x minus y into I minus yz square j minus y square zk, where s is the upper half surface of the sphere, x square plus y square plus z square is equal to 0. C is its boundary. That is a curve. Here, very important thing is we are considering C is a simple closed curve and S is a surface, right? So now here they are given in a three-dimensional. Convert this three-dimensional into two-dimensional such that here in this sphere make Z is equal to 0, right? So what to do here? So first let us write down solution. Green's theorem, sorry, Stokes theorem. By using Stokes theorem, what is the formula? By using Stokes theorem, first we have to write the formula. Okay, what Stokes theorem says that, so line integral over C f dot dr is equal to a double integral over surface. Okay, that surface is a plane. Now that is curl dot f, curl f, that is equal to curl f, nothing but curl dot f dot n cap into ds. This is we need to verify. Now let us find out f dot dr at the first thing. F dot dr. What is f here? Okay, I can write dr vector is equal to, I can write dxi plus dyj plus dzk. Am I right here? Now write down f vector to make this one. What is f vector? They are given 2x minus y into I minus yz square into j minus y square z into k. Make dot product of this. So what happens here? F dot dr. Okay, f dot dr or dr dot f. Dot product is commutative. So this become I dot I is 1, j dot j is 1, k dot k is 1. Just component wise multiplication. 2x minus y into dx minus, here what happens here, yz square into dy minus y square z into dz. This is what f dot dr. Now let us find out the thing here. Okay, now have a look on this. Here the C they are given. Here C is the curve. C is the curve. What is the curve here? Here the C is the curve where z is equal to 0. Here this is a curve, x square plus y square plus z square is equal to 0, z is equal to 0. That means what? X square plus y square is equal to 0. That becomes, not that is 0, that is 1. Sorry, I am sorry. This is 1. Okay, x square plus y square is equal to 1. This represents a equation of a circle. This is a circle which represents a circle, which represents a circle. I can write which represents a circle. Center at 0, 0 and radius 1. This is, we call it as unit circle. Okay. Now we have to write the parametric equation here. Since it is plus and square of this should be equal to 1, we have the property sin square theta plus cos square theta is equal to 1. So that x is equal to cos theta, x is equal to cos theta and y is equal to sin theta. Always x coordinate is taken in terms of cos, y coordinate is taken in terms of that. So now if you differentiate this, what happens here? Dx is equal to minus sin theta into d theta. Am I right? And this dy is equal to cos theta into d theta, since it is a parametric equation. Now let us find out a line integral C f dot dr, the first equation, that is equal to line integral C f dot dr. What is f dot dr here? We have calculated already. What is 2x minus y into dx minus yz square into dy minus y square z into dz. Okay, under the boundary condition, what we have here? Under the boundary condition, what we have here? Okay, here the z coordinate is 0. Already we have taken z is equal to 0. Since it is a two-dimensional, z here goes up, z here goes up. Remaining is 2x minus y into dx. I can take, so where to where, since it is a circle which is taken from 0 to 2 pi, am I right? So here you can make theta is from 0 to 2 pi. It is a circle, the complete cycle, 0 to 2 pi. So 2 into x is nothing but cos theta minus y is nothing but sin theta into dx. What is dx here? Dx is minus sin theta into d theta. Minus sin theta into d theta. Okay, this we can simplify this. What happens here? So 0 to 2 pi I can take. So this is the value of theta, right? I'm right here. Okay, now multiply 2 cos theta into minus sin theta minus 2 sin theta into cos theta minus into minus is plus. Sin theta into sin theta is sin square theta into d theta. Okay, dear children, so 0 to 2 pi, I can make 0 to 2 pi, make this one, minus 2 sin theta into cos theta is sin 2 theta, plus sin square theta is not directly integrable, right? So for that we have to make like this, half into 1 minus cos 2 theta. So this entire thing into d theta. So got my point? Sin square theta is 1 minus cos 2 theta by 2, that can be written as half into 1 minus cos 2 theta. If it is cos square theta, make that half into 1 plus cos 2 theta. Now just you have to integrate this. So what happens here? So that is equal to, I can make integration here, minus is there, sin is nothing but minus cos 2 theta divided by 2 plus half into, have a look on this, integration of 1 is theta because with respect to theta, minus cos 2 theta is sin 2 theta by 2, from where to where, 0 to 2 pi. Just apply the upper limit and lower limit here. Okay, after applying the upper limit and lower limit, what happens here? Okay, have a look on this. I hope these things are very clear to you. Okay, now make this, I think it's okay. So the minus into minus is plus, minus into minus is plus, this become, apply the upper limit, 2 pi. So cos 2 into 2 pi, what happens here? Cos 4 pi divided by 2 plus half into, theta is what? 2 pi minus, theta is 2 pi, sin 4 pi divided by what? 2. Okay, this is what upper limit, minus we have to write the lower limit. What is lower limit is 0, minus into minus plus, cos 0 by 2 plus half into, theta is 0 minus sin 0 divided by 2. Just simplify this, So this become ultimately, I can write cos 4 pi, multiple of pi, even pi, so 1 pi, okay, 2 pi is 1, again 4 pi is 1, this become 1 by 2 plus half into 2 pi minus sin 4 pi is 0, 0 by 2 is 0, okay, minus cos 0 is 1, this become 1 by 2 plus half into 0 is 0 minus sin 0 is 0, 0 by 2 is 0, this is. Now just simplify this, this is 1 by 2 plus 2 to get cancelled, that is 5, here that is what you will get, minus 1 by 2. So these two get cancelled, remaining is 5, this is line integral C f dot dr. This is equation number 1, this is the LHS part. Now we have to find out the RHS part, right? So now let me know the RHS part. I think this part is over, right? Okay. Now go with the RHS part. Sir, what is RHS part is, sir? Double integral over the surface curve f dot n cap into ds. Okay, let us find out. It's an easy way to understand that. It's very simple. Why it is x square plus y square plus z square is equal to 1 is taken as x square plus y square is equal to 1. By making z is equal to 0 means we are discussing under plane, it containing only x and y, therefore make z is equal to 0 in all these things, right? So now find out the RHS part. What is the RHS part here? First let us find out curl f, right? So curl f is nothing but, so del cross f I j k. Now we have to write curl f. So components 2x minus y, we can make some space. j cap minus yz square is there. Minus yz square. Okay, minus yz square is, sorry. We have under I, we have to write dou by dou x. Under j, dou by dou y. So under k, dou by dou z. Okay. Now write down what is dou by dou x is. Sorry, that is what 2x minus y. F component. Here minus yz square. Here minus y square z. Now expand this and apply the partial derivative. So what happens here? This become, what happens here? Okay, this become I into, I can make I into dou by dy of this is minus 2yz. Just differentiate y. Minus 2yz, in between that minus. Dou by dou z of minus yz square. This become minus is there, 2zy become plus 2zy plus 2zy. Okay, minus j into dou by dou x of this, there is absent of x, 0 minus, there is absent of z, this is 0, plus k times of, have a look on this is by this, there is absent of this, that is equal to 0 minus, there is absent of y, x is there, therefore derivative is 0, minus y, that become minus 1. Okay, after simplifying this, what happens here? So minus 2yz plus 2zy into I, and this become plus 0j, and this become minus into minus plus 1k, that is nothing but k. So now what to do here? But actually, z is equal to 0, as you know that, but z is equal to 0, 0, 0, that become what? 0i plus 0j plus k is remaining. This is what correlate. But how to take this one, sir? So now n cap dot ds. As you know that n cap ds is nothing but dy dz I plus dz dxj plus dx dyk. Okay, am I right? So now just dot product this. So curl f dot n cap ds. What happens here? Dot product I component is 0, 0 into that, 0 into that. K is remaining is k dot k is 1. What's the remaining thing is dx into dy, nothing but 1 into dx into dy. Okay, now we have to make this one. Okay, this therefore RHS part double integral s curl f dot n cap ds is equal to double integral s. So 1 into dx into dy, and you know that this is nothing but area of the curve, nothing but circle. So area of the curve. Here what is the curve? Curve is circle. Okay, area of the circle is pi r square, but r is equal to 1, already discussed that, because x square plus y square is equal to 1, radius is 1, this become pi. This is what? S curl f dot n cap ds. Am I right here? Equation 2. From 1 and 2, both of the answers are same. Nodi. From 1 and 2, we can get LHS is equal to RHS. Therefore, we verified the Stokes theorem is verified. STV, that is Stokes theorem is verified. Don't write like this, STV. So you have to write completely Stokes theorem is verified. Am I right here? Okay, and then thereafter we can discuss one very important theorem of Stokes theorem. What is that, sir? Verify Stokes theorem for vector. I can make something here. The question is yi plus zj, f is equal to, have a look on that, yi plus zj plus xk, upper half of the sphere and c is its boundary. This is what. So now by using Stokes theorem we can write this one. Now let us find out f dot dr for the LHS part. Okay. Dear students, understand this is very important problem too. Okay, now how can you make this one, sir? Okay, now let us take this one here. So as you know that dr vector is equal to dxi plus dyj plus dzk. Okay, now so f what they are given, f is yi plus zj plus xk. So what happens here? Y dx. Okay, f dot dr. Make the dot product for this f dot dr. So y dx plus z dy plus x dz. This is what. Okay, now consider the curve. What is the curve here? Let the curve is what? X square plus y square plus z square is equal to 1. Since curve is a plane, make z is equal to 0. Therefore, C is a circle. Okay, z is equal to 0. To make z is equal to 0, x square plus y square is equal to 1. As you know that. So it represents a circle. Represents a circle. As usual, represents a circle with r is equal to 1 here. Okay, radius is 1. Take the parametric equation as usual. X is equal to cos theta, y is equal to sin theta, and theta, since it is a circle, theta is varies from 0 to 2 pi. Am I right? This is a boundary condition. So now differentiate this. Dx is equal to minus sin theta into d theta, and dy is equal to cos theta into d theta. Just find out the LHS part here. What is the LHS part? A line integral over C f dot dr, that is equal to line integral C. C is nothing but 0 to 2 pi here. Okay, the boundary condition 0 to 2 pi. F dot dr is y dx plus z dy plus x dz. As you know that, dear children, the z is equal to 0. When z is equal to 0, dz is also obviously is equal to 0. So what happens here? Okay, y is equal to what? 0 to 2 pi. So y is equal to what? This y is equal to sin theta into dx is equal to minus sin theta into d theta. And here this z is equal to 0 vanishes. Here dz is equal to 0 vanishes. Okay. Here as z is equal to 0, that implies dz obviously is equal to 0. Right? If you differentiate that. So now you will get minus sin square theta. So take minus outside, 0 to 2 pi minus, I know that, so we know that to integrate this sin square theta, this can be taken as half into 1 minus cos 2 theta into d theta. Here we left d theta. So that is equal to minus, integrate this, so half, take it outside, 1 is theta minus cos 2 theta is sin 2 theta divided by 2. From where to where? 0 to 2 pi. Now for keep minus 1 by 2 outside, what happens here? 2 pi minus sin 4 pi is 0 by 2 is 0. This is the upper limit minus lower limit. Theta is 0 minus sin 0 is 0. 0 by 2 is 0. So answer is 2 to get cancelled, that you will get minus pi. This is a line integral C f dot dr. Let it be equation number 1. Am I right here? This is the LHS part. Now we have to find out the RHS part of this. Understand this. Okay, now what is RHS, sir? I think everything is clear, right? Why it is z is equal to 0? Because we are dealing under plane, xy plane. That's why. Okay, now RHS part. To make the RHS part, what are the quantities here? Have a look on this. RHS is, what is RHS? First we have to find out in the RHS curl F. Curl F is nothing but del cross F. So let curl F is given by determinant of I, J, K and dou by dou X, dou by dou Y and dou by dou Z and F component here. Okay, what are the F component? Here Y, here what? Z, here X. Okay, what happens here? I into, so this is, so partial derivative of X with respect to Y is 0, partial derivative of Z with respect to Z is 1, minus J into, make this 1. So that is equal to 1, minus this becomes 0, plus K into what happens here? That is equal to 0, minus, this is Y is there, 1. Okay. So that become what? Minus I, minus J and minus K. So minus I, minus J and minus K. Okay, now actually we know that this is what curl F. Now n cap dot ds. What is n cap dot ds? So that is given by n cap into ds, right? So that is equal to dy dz into I plus dz dx into j plus dx into dy into k. Now simplify this. What happens here? Minus dy dz minus dy dz minus dz dx and minus dx dy. One thing you should understand here, where when z is equal to 0, already said that dz is 0. Here also dz is 0. When it goes up, remaining thing is what? Minus dx dy. Minus dx dy. This is what n cap, sorry that, this is what curl f dot n cap ds. So curl f dot n cap ds. This is what minus dx dy is remaining. Now find out the RHS. What is RHS here? So double integral over s curl f dot n cap ds, that is equal to double integral over s. So the entire thing can be taken as minus dx by dy. So if you take minus outside, double integral over s dx into dy, this gives the area of the curve, that is equal to minus outside is there, area of curve. That curve is what here? Circle. Therefore that is equal to minus, area of the circle is pi r square, but r is equal to 1. What happens here? Minus pi. This is a double integral over s. So curl f dot n cap ds. That will be equation number 2. From 1 and 2 you will get the same answer. From 1 and 2 LHS is equal to RHS. Hence Stokes theorem is verified. Am I right? Is okay. I hope you all understand the line integral concept, Green's theorem concept, and now the Stokes theorem concept. Have a great day. Thank you.